Assalamualaikum and hello everyone. My name is SMG3013 binti Musada. Today we would like to present our geometry assignment with the code SMG3013. The theme that we chose is architecture and the object is Rumah Za'Ba. The next is our group members. The first one is Nik Wafa Zahiyah binti Mak Hussein. The second one is Nur Aina Nadia binti Muhammad Iswani. The third is Hafida Alisa binti Musada. The fourth is Muhammad Fitri Alihas bin Sahidi. And the last one is Obi Oliver Jikos. The next is Za'Ba House background. Za'Ba House is a traditional Malay heritage building located at Upsi, Tanjung Malim, Perak. It was formerly the residence of Pendeta Za'Ba, a prominent Malay scholar and writer during his service at SIPC 1924 until 1939. Today, it has been restored and preserved as a museum showcasing his contributions to Malay language, education and literature. The house reflects traditional Malay architecture featuring elements such as timber structure, elevated floor and symmetrical design. Next is location. Rumah Za'Ba is located at the Sultan Abdul Jalil Shah campus of Tanjung Malim, Perak. It is part of the university's heritage, are linked to the history of SIPC and serve as an educational heritage site. Next is usage, function. Originally, the house was the residence of Pendeta Za'Ba. It was later used as a gallery and security post before being restored as a heritage museum displaying his work, manuscripts and historical collections.
Za'Ba House consists of three main sections, which are the main sections, middle section and grand sections. The overall structure of the house is based on rectangular shapes. The first section is the veranda in the shape of a rectangle with length 3.68 meter, width 3.53 meter and height 3.60 meter. Next, for the middle section, the front section is also a veranda in the shape of a rectangle with length 3.34 meter, width 6.26 meter and height 3.60 meter. For the rear section, the front section is a veranda in the shape of a rectangle with length 3.6 meter, width 1.15 meter and height 2.80 meter. The layout consists of interconnected rectangular shapes and the structure is supported by uniform pillars, which is mainly 3.60 meter. Hence, the Za'Ba House can be modeled as a combination of rectangular prisma based on its structural and geometric configuration.
There are several geometric shapes that we can identify in Rumah Za'Ba. That's including rectangles, rectangle prism, isosceles triangles and right angle triangles, which are used in different parts of the building structure. And the windows and the door of Rumah Za'Ba are in the shape of rectangles. And by definition, a rectangle is a two-dimensional quadrilateral with four straight sides, where opposite sides are equal in length and parallel, and all interior angles measure 90 degrees. And we can calculate the perimeter and the area of the rectangle, which is for the perimeter of rectangle can be calculated by multiplying the sum of the length and the width. And when we substitute the value, we will get the answer 4.48 meter. And the area of the rectangle can be calculated by multiplying its length and width, which is we will get the value of 1.2444 meter square. Next, the roof section of Rumah Za'Ba can be identified as a two-dimensional isosceles triangle. And by definition, An isosceles triangle is a triangle with two sides of equal length and two equal base angles. And this is the example. How do we calculate the perimeter and the area of the triangle, which is the perimeter is we can calculate by the sum of the length of its three sides, and the area of the triangle is given by half of the product of its base and height. When we substitute the value that we get from the measurement, we will get the perimeter of the roof section, which is 7.08 meter, and the area is 1.76 meter square.
Now we go to the pillar footing of Za'Ba house. It's shaped like a cupboard or rectangular prism. The rectangular prism is a three-dimensional solid with 6 rectangular faces, where opposite faces are equal and parallel, and all interior angles are measured 90 degrees. So, since the base is rectangle, the perimeter can be calculated by multiplying the sum of length and width by 2. So we can get perimeter is 1.5 meter. So next, the lateral area. It can be calculated by multiplying the height of the object by its perimeter. So we can use the formula L equal to HP. So we substitute, and we get 1.245 meter square. Next, we go to the base area of the rectangle prism. Is given by the product of its length and width. So for the base area, we times the length and width, and we substitute, and we got 0.14 meters square. And the total surface area of a rectangular prism is given by the sum of the total area and the twice the base area. So we calculate by using A equal to L plus 2B. So we substitute and we get 1.525 meters square. And last but not least, the volume of the rectangular prism is given by the product of its length, width and height. So the volume we calculate by using V equal to length, width and height. We substitute and we got 0.1162 meter cube. Next, we go to the knee brace in Rumah Za'Ba that can be identified as a right angle triangle that formed by a vertical pillar and horizontal beam. The 90 degrees angle between them confirm its geometric properties. So the perimeter of a triangle is given by the sum of the length of each side, and the area of triangle is given by half the product of its base and height. So for our right triangle, so we can conclude the perimeter we get is 2.13 meter, and the area after we substitute is we get 0.1872 meters square.
The next we will move with 2.3, which is transformation in motif and patterns. Transformation geometry can be found in many parts of Rumah Za'Ba through its motif and patterns. A motif refers to a single decorative or structural element, while a pattern is formed by repeating the same motif in an organized arrangement. These transformations not only enhance the visual appearance of the house but also demonstrate mathematical concepts such as reflection and translation in traditional Malay architecture. Okay, for the first one, 2.3.1, transformation in motif. We identify 3 transformation in motif from Rumah Za'Ba. The first one is the wooden window. For the wooden window, 4 rectangular panel in a 2x2 layout configuration function as ventilation and natural lighting opening. For the second one is the railing bar. For the railing bar, a single rectangular bar on the veranda serving both structural and decorative purpose. For the last one is the wooden plank. For the wooden plank, a single rectangular plank on the wall identical to its neighbor in size, shape and orientation. So next we will move with the 2.3.2, which is the transformation in patterns. we identify three transformation in patterns from Rumah Za'Ba. The first one is the window pattern. Identical window motif repeat horizontally along the facades at equal height and size. Translation: the overall arrangement also contributes to the building's reflection symmetry. So the second one is the veranda railing pattern. For veranda railing pattern, vertical railing bars repeat side by side at constant spacing along the veranda. It is transformation producing a rhythmic uniform visual effect. For the last one is the wooden wall plank pattern. It is horizontal planks repeat at regular vertical intervals across the wall. It is translation, creating a continuous uniform surface. So the transformation involved in these three patterns is the translation.
Okay. Last but not least, summary and conclusion. This assignment helps us see how class geometry connects us to real buildings. So, by analyzing Rumah Za'Ba, we learned that architectural shapes have specific purpose. For example, the right angle knee brace distribute roof weight, and the isosceles triangle roof helps drain tropical rainwater. Ultimately, this project improved our math skills and show us how geometry shapes the world around us. So that's all from us. Thank you.